What if everything you see, everything you know, was about to be not in a movie, but inside the memory of a machine? For decades, it's been the ultimate science fiction dream, a perfect copy of our reality, from the tiniest particle to the biggest galaxy cluster. But it brings a terrifying new question with it. If we can build a machine that simulates a universe, what happens when we look inside and realize we might already be in one? And now, scientists aren't just dreaming anymore. They're retaking the first real steps toward building a quantum artificial intelligence powerful enough to simulate our entire universe. This incredible goal could finally answer our biggest questions about existence, time, and the cosmos itself. This isn't just speculation. The parts are being built right now in labs all over the world. We are at the dawn of a technology so powerful, it forces us to question the very nature of reality. The line between the creator and the created is starting to blur, and we're standing right on that line, looking down into the abyss. What we find there could change what it means to be human, or reveal a truth we were never meant to find. The grounding to even begin to grasp how we could simulate a universe. We have to look at two revolutionary technologies that are starting to merge: quantum computing and artificial intelligence. First, let's talk about quantum computers. The computer or phone you're using right now thinks in bits, simple ones and zeros. It's a black and white world of on or off. But the real universe doesn't work that way. AI, especially machine learning, is amazing at finding patterns in huge, messy datasets. We see it every day in our recommendation feeds and in medical scans. That task is still almost impossibly complex. Today's quantum computers are mighty, but they're also noisy and make errors. Scaling them up to handle millions of stable, interconnected qubits is a massive challenge. Still, the journey has begun. Scientists are no longer asking if we can simulate quantum reality, but what parts of it we should tackle first. And the answers we're getting are already starting to change everything. But when you power an AI with the almost infinite landscape of a quantum computer, you get something entirely new. You get an intelligence that doesn't just process data, but explores possibilities in a way that actually mirrors the quantum universe itself. It's still early days, but this combination is already producing results. Companies are building hybrid systems, blending classical AI with quantum processors, to speed up the creation of new quantum algorithms and make these incredible machines easier to use. Down at the smaller scales, the world is a chaotic storm of probabilities and possibility. This is the world of quantum mechanics. A quantum computer uses qubits, which are like tiny spinning coins that can be both heads and tails at the exact same time. This is called superposition, and when you add in another bizarre effect called entanglement where two qubits become linked, no matter how far apart they are, these machines can process an amount of information that is exponentially greater than any normal computer could ever hope to. Trying to simulate even one complex molecule can bring a supercomputer to its knees. But for a quantum computer, it's what it was born to do. As the great physicist Richard Feynman famously said, nature isn't classical data. And if you want to make a simulation of nature, you'd better make it quantum mechanical. Now, imagine giving that raw power an intelligent mind. That's the birth of quantum AI. But let's be clear, even with this breathtaking speed, we are not about to create a perfect, one-to-one copy of our universe tomorrow. The what if so? What's the ultimate prize? If we eventually build a true digital twin of the universe, what secrets would it tell us? The possibilities are as staggering as the cosmos itself. We could see the first stars flicker into existence and watch galaxies form from clouds of ancient gas. Those huge cosmic mysteries, dark matter, and dark energy would no longer be invisible ghosts. In a perfect simulation, we could poke and prod them, change their properties, and see how the universe responds. We could finally figure out what this invisible cosmic web is made of, and what strange force is pushing our universe to expand faster and faster. Imagine a lab where you could rewind time and watch the Big Bang happen, not as a theory on a blackboard, but as a live event. It's a tool for exploring not just our universe, but all possible universes. This is the incredible promise that drives research. It has the chance to go from being passive observers of the cosmos to active explorers of its deepest secrets. But with great power comes great risk, and this new frontier is no exception. The power to create worlds forces humanity to face questions we've never had to ask before. The idea of digital twins is being used to create perfect digital copies of real-world systems. For example, quantum AI can simulate how molecules interact at the atomic level. A true simulation of the universe would be the ultimate science experiment. It would be a sandbox where the fundamental laws of physics are just the starting blocks. we could finally ask the deepest questions. Are the laws of physics the same everywhere and for all time? What really happens inside a black hole? Could life exist if the rules of physics were just a little bit different? This could completely change how we discover new drugs, letting scientists design and test new medicines with unbelievable speed and precision. The same idea could be used to invent new materials for batteries and solar panels, or design incredibly efficient supply chains to help fight climate change. On a smaller scale, this technology is already being used to solve problems right here on Earth, but the final goal is so much bigger. We could run 1 billion different versions of the universe, tweaking the recipe each time, just to see which ones create life, consciousness, or something else we can't even imagine. The first glimmers. This isn't just a wild idea. Around the world, scientists are already running simulations that are giving us the first tantalizing glimpses of this future. They're like the first blurry photographs of a new world, hinting at what's to come. One of the most mind-bending experiments deals with a cosmic doomsday scenario called false vacuum decay. It's a theory in physics that says our universe might not be in its most stable state. Think of it like a ball resting in a small dip on the side of a huge mountain. But recently a team of scientists used a special type of quantum computer to actually simulate this exact process, and even model how light can appear to emerge from the nothing of the quantum vacuum. These aren't simulations of the whole universe, not yet, but they are the essential first steps. With each one, we learn how to build the tools, write the code, and ask the right questions. We're learning the letters of a cosmic alphabet. Soon, we might be able to put them together to read the source code of reality itself. They used over 5,000 qubits to create a simplified, one-dimensional model of a false vacuum, and they watched as bubbles of the true vacuum formed and grew. It was the first time anyone had ever seen this process play out, something that would be impossible to see in our own universe. This experiment doesn't mean our world is about to end, but it's a stunning proof of it. Proves we can now use these machines to get a front row seat to the processes that decide the fate of the cosmos. It seems stable, but it's not in the deepest possible valley. A false vacuum is a state that seems stable but could suddenly tunnel into a true vacuum, a new state with lower energy. If that happened, the very laws of physics would change in an instant. A bubble of this new reality would appear and expand at the speed of light, rewriting the universe as it went. For decades, this was just a scary story told with complex math, and it's not just happening there. In other labs, scientists have used quantum simulations to recreate bizarre states of matter. The turn, and this is where the story takes a sharp, unsettling turn. The closer we get to building a machine that can simulate a universe, the more we have to face one of the oldest and most disturbing questions of all. Are we living in a simulation right now? This is the simulation hypothesis, made famous by the philosopher Nick Bostrom. His argument is a chilling piece of logic, but quantum AI drags it out of the philosophy class and into the world of real science. If we are actually on the path to creating these simulations ourselves, then we are providing the first piece of evidence that it's technologically possible. It goes like this. If any civilization ever develops the technology to create realistic simulations with conscious beings inside, they would probably create billions of them. If that's true, then the number of simulated minds in existence would be vastly greater than the number of real minds in the original base reality. So, for any random conscious person alike, the statistical odds are that you're far more likely to be one of the many simulations than one of the original few. As it looks deeper and deeper into the fabric of its own simulated reality, it finds weird patterns, glitches in a matrix, you could say. Patterns that don't look random, but look like they were written by someone. An underlying code. No one has found anything like this yet, but just thinking about it raises huge questions. For a long time, this was just a fun thought experiment. So, imagine this. In the near future, a powerful quantum AI is built to simulate a universe from scratch. The most terrifying one isn't what happens if we create a conscious simulation, but what it means about our own world. If we can create a universe in a box, why couldn't some other, more advanced civilization have done the same thing for us? Our reality, our thoughts, our feelings, our sense of self could all just be the output of a very sophisticated program. It would challenge everything we think is real. Do we really have free will, or are we just following a script? Does life have any meaning, or are we just a science project for someone else? And maybe the scariest thought of all, if our universe is a simulation, could whoever is running it interfere? Could they change the rules, or just shut it all down? The limits of creation. But before we spiral into a full-blown existential crisis, It is important to know that science itself might prevent us from ever creating a perfect simulation of the universe. The same laws of physics that make a quantum computer possible might also be the very things that stop it from ever perfectly copying our reality. The first big roadblock is something at the very heart of quantum mechanics: randomness. The quantum world isn't a predictable machine. It's a world of pure probability. You can never know with total certainty both the exact position and the exact momentum of a particle at the same time. This isn't because our tools aren't good enough. It's a fundamental rule of the universe. The amount of information you would need to track the quantum state of every single particle in the observable universe is a number so big it's basically meaningless. A normal supercomputer's memory would overflow trying to store the data for just a few hundred qubits, while a quantum computer is a whole different animal. Simulating the entire universe would probably require more resources than the universe itself contains. This built-in uncertainty means that even a perfect quantum computer could never create a perfect, predictable copy of our cosmos. It could create a universe that plays by the same rules as ours, but it could never be an identical replica, down to the last particle. Then there's the sheer size of the problem. There is also a deep debate among physicists right now about whether quantum reality can ever be fully simulated. Some theories suggest that the deeply interconnected web of quantum information, with all its weird faster-than-light links, makes it fundamentally impossible to copy. In other words, the universe might just be its own best and fastest computer. Any attempt to simulate it from within itself would be doomed to fail. These limits suggest that while we can build better and better maps of reality, we may never be able to build the territory itself. This quest to simulate the universe is pushing us to the absolute edge of what we know about reality. The machines we're building aren't just scientific tools. They're mirrors, reflecting our deepest questions right back at us. We are creating systems that can model the birth of stars, the dance of molecules, and maybe, one day, even consciousness. We are evolving from a species that just lives in the universe to one that is starting to understand its source code. We're learning to speak its native language, quantum mechanics, and with that knowledge, we may unlock powers we can only dream of today. On one side is the answer to everything. On the other, the terrifying realization that our own reality isn't what it seems. We are standing at the edge, looking into the code of creation itself. Or are we just discovering the rules of a game that's been playing us all along? Let me know your theories down in the comments. And if you want to keep exploring the frontiers of science and what it means to be human, make sure you subscribe and hit that notification bell. The question is no longer just can we simulate the universe, but what will we become when we try? In doing so, we are forced to look at our own place in the cosmos. Even if a perfect simulation is forever out of reach, the journey itself will change us completely. But this journey is like walking on a razor's edge. What do you think? As we build these new worlds, are we playing God?